And we're live. Hey everyone, welcome to another episode of Stripe Dev Chats. My name is Cecil Phillip. And today we have a really interesting topic because we're going to be talking about something that we don't talk about often enough, and that's security, right? And what are some of the things that we need to do and think about as we're trying to secure our applications? And so my teammate Charlie is here, and me and her are going to have a conversation with some folks from Socket who are going to tell us about how we can protect our JavaScript applications through through the bad people and the bad things that might happen. So Charlie, you want to introduce yourself, holy folks, and just say hi to everybody?
Sure. Hi, I'm Charlie. I'm a senior developer advocate at Stripe, and I'm really excited to talk about security today because it's something I've been looking into on my personal time. So I'm really excited for today's chat.
Awesome. I know we have these two amazing gentlemen here from Socket. So folks, why don't you introduce yourself? Feross, do you want to start and go first?
Sure. Hi, everyone. My name is Feross. I am a longtime open source maintainer and now working on Socket, which is a startup that helps developers use open source safely.
Awesome.
My name is Amjed. I'm running go-to-market efforts for Socket. Honored to be on Dev Chats today, and just want to give a special thank you to Cecil and Charlie for having us.
Sure. We're definitely really excited that you're here. So I have something I need to admit to you and everybody else. I always think about security last every time I'm building an application. I'm one of those like stereotypical developers that like I build and I build and I build. I test it out. Okay, it works. And now I'm like, oh, I need to think about how I should secure this thing. And not only just secure it from the perspective of like authentication or authorization or roles and permissions, but actually thinking about, hey, is my application actually protected? Is my code actually protected? When I, publish and update things, like, are they actually protected? And are there things I need to be concerned about when I'm, deploying my application for other people to consume? So I'm sorry, and I apologize sincerely to you and everyone else that's here. But I'm hoping that, you two gentlemen could definitely let me know about some of the things that we could, can and should pay attention to when it comes to like securing our Node.js applications and our JavaScript applications specifically. So,
totally, yeah.
For us, so I know you have some like insight into like, what are the things that people that are publishing or even consuming NPM packages, like what are some of the things that you should be concerned about, right? And why is like that even a problem? Like, would you mind like giving us a little bit of background around, again, like what are these problems that we should try and pay attention to, and like what are some of the things that we can do to mitigate those problems?
Yeah, for sure. And let me just say, Cecil, if you're thinking about security last, then you're really making a lot of work for yourself. It's a lot easier. Yeah. It's much easier if you think about it from the beginning and throughout the whole process. And one of the things I always say is, you have to almost think like an attacker, in order to make your apps secure. You have to have that mindset of like, how could somebody break this? How could somebody, take advantage of the design here? And if you think about that throughout the process, you're going to have a much better outcome in terms of, the security of the product. Because some mistakes, you can't really fix them once you've, it's a lot harder to fix them after the fact.
Yeah, again, you're right. You know what? It reminds me of, it's like testing, right? Like, you should test your application as you're building it. But we don't really do that. We wait until the end and be like, okay, let me write some unit tests and let me see if it happens. You know what I mean? Again, I know. It's like what you're supposed to do, but then actually doing it, is a different thing. And I even thinking about that, there might be a lot of reasons why that's the case, right? Maybe the tools that enable us to do that, maybe they're just hard to use and they're just not fun, right? Maybe they take long to set up, right? And maybe there's just a lot of things that have to happen. So now I'm just like, oh, okay, well, I'll just do it later. Right. So I think, and I'm not a tooling person, but I also think maybe it's just a case of sometimes these tools just need to be a little bit more developer friendly, I suppose, and a little bit easier so that we're like, oh yeah, I want to use this thing. I want to plug it into my app early so I get to play with it. Because, I know when I think about databases and, plugging into APIs, like I'm excited to actually try them out. Right. So I think as an industry, we should think about ways that we can make things like security and testing and stuff like that exciting. So we want to do it like from the beginning.
Totally, yeah. And I think that we can do that with Socket and some of the stuff I'm going to show today. It's actually pretty cool. And like I mentioned, I've been an open source maintainer for quite a long time now, and so I come at this from like the developer perspective, and it's something that I care a lot about, the developer experience being good. So yeah, definitely excited to jump in and like share what we've been working on, and hopefully get folks excited by it, because I think it's really cool stuff. We're even going to show some actual attacks, like npm packages that have been booby trapped and filled with malware and stuff that you don't want to install on your computer, but we'll go into kind of how it works. And I'm happy to show that there's a lot of really interesting, let's say interesting is probably is underselling it, some gnarly stuff out there on npm that you definitely don't want to install. So happy to show that to y'all.
Okay, well, why don't we go ahead and just dive into it? I'm going to pull up your screen in a second, and maybe you can let's start off with just talking about what are some of the things that we should be paying attention to, and then we'll kind of dive into Socket, and then just see some examples of how Socket helps us deal with that. Does that make sense?
Yeah, let's do it.
Good. All right, cool. So I'm going to bring up your screen now, and there you go. So your screen's up. So I see your slide deck, protecting JavaScript apps from malicious dependencies with Socket.
Cool. Yeah, so I'll just go through a few things here, and then we can take questions, and I can do some live demos of how to use Socket. But let me just get started with a little bit of background on kind of my experience. So been a maintainer for quite a while now, written a bunch of kind of open source packages in the npm world that get quite a few downloads. And that's actually, quite honestly, a big part of why I got interested in security. Was I started thinking about how many different companies use my code, and just the risk that they're taking on by just using the code of a random person such as myself on the internet, and just sort of that's the way we build our apps today, and it got me really interested in security. So I kind of moved into that and started teaching a course on web security at Stanford University, and then now I'm working on scaling open source security for many organizations, and doing that at Socket. So let's start just really quickly by covering kind of what is the software supply chain, because this is something that you probably you'll hear a lot of people talking about today. And really, it's nothing crazy. It's just the set of all dependencies and components that make up our software. So it includes things like APIs, cloud services, and obviously open source dependencies. Really, all the parts and pieces that make up our software, right?
So would you call it the parts of our software that we don't necessarily control? So I want to say don't control.
Yeah, I think that's right. Yeah,
I didn't write the package. I didn't, build the thing. I didn't create the database or the cloud, right? But I can control my code, right? So would you consider that the supply chain, all the things on the outside of that?
Yeah, totally. Yeah. And it's really just all this stuff. Actually, the term supply chain comes from the physical world, where people usually they refer to the parts that go into making an iPhone or making some kind of hardware device. And the supply chain is just all the pieces and parts and vendors that you have to get your parts from. And so that's kind of the analogy being made in the software world. It's sort of what are all the pieces that go into making our software?
Got it.
Yeah. So yeah, it's like I said, I've been kind of doing this for a little while now, and I've seen kind of the rise of attacks against the supply chain starting to happen. And so I wanted to just start by kind of going over why are so many attacks happening now? What has changed, and what is different about the way we do software today? So there's really three things I think to focus on. The first is we just have a massive increase in the number of third-party dependencies that we are using. So this is really because of the way that we write software changing. So from whether it's, like I said before, the cloud or APIs that we're using, or even no-code tools, and obviously open source, no one is really writing their software from scratch anymore. So if you look at the average company today, they have around 177 different SaaS services that they're using, and then if you go to the actual kind of open source side of it, the average package that you would install from npm itself brings in 79 third-party packages. So you just have this sort of sprawling set of other people out there, other companies, other individuals that you're depending on every time you install a package. So this is a hard number to believe, I think, for a lot of people, but actually it's true. The average package has 79 other packages that it depends on. And so those all get installed whenever you install one package.
That's kind of scary when you think about it, to be honest with you, because Like
Yeah.
even as I install, I don't know, let's say I install Socket.io, right? Or if I install like Express or something like that, like I only know about that top level dependency, right? And then I
Right,
don't know
right.
about all the other things that they're depending on, which I mean, I get it. Like I think software usability is important, but it can also be scary too, right? Because I don't know what's under there, right?
Yeah, and like, look, I don't want to like call out open source in any way because like I worked on it and contributed to this exact problem that I'm that I'm talking about myself.
Okay.
So obviously, open source is awesome. It's like how we're able to build our apps so quickly, and we can get stuff like off the ground in days that would have taken like months or years before. So it's
Yeah.
obviously great. And I don't think we're ever going to go back to the old way of writing software where everybody just wrote everything themselves. Open source is awesome, but we just have to acknowledge that there are risks when we're depending on this many different people around the world. Because if you have even one bad apple, then it's easy for that one individual to affect a lot of people.
So Sean,
I like this.
Jumping in really quick. I'm sorry, Sean, jumping in from YouTube. Sean is asking, so does the 79 transitive dependencies include build dependencies as well?
Yeah, so I think that 79 number is including dev dependencies. I think the number goes down a bit when you take those out, but you still end up with a number that's in the double digits for sure. Yeah, that comes from a paper. We can maybe drop the link in the chat, but there's a study that was done at a university that sort of like analyzed the whole registry and found that was the number of transitive dependencies.
Gotcha. Cool. All right. Thank you for your question, Sean. All right. Feross, you want to go ahead? Keep going.
Yeah, of course. Yeah, feel free to keep jumping in with questions as we go. I just wanted to show this cool visualization here. So this is Webpack, which is like a thing that most of us use in our apps. It's the main kind of web bundler that prepares our JavaScript for usage on the front end. And what you're seeing here is every gray box is a package, and every purple box is a file within that package. So what you're seeing here is as we peel back the layers, we peel back the layers of packages, and you see that there's more packages inside and more files inside. And then we peel back another layer, and it just keeps going. So this is just our attempt at Socket to kind of show in a visual way like what is the kind of complexity we're dealing with here when we install even a single dependency such as Webpack. It's oftentimes it's surprising for people, especially if you've never opened up the node modules folder on your computer and like looked inside there to see kind of like what is going on. But yeah, it's really a lot of packages, and so for that reason, it's probably not surprising that 90% of an application's code comes from open source packages. This is just kind of how we do it today. So that's the first reason. In terms of kind of the second reason why I think we're seeing more attacks is, besides just now we're using a lot more open source, is we're also moving a lot faster. So it used to be in the old days that companies would release their software once a year. There was like a yearly release, and now we do it like hundreds of times per day sometimes, right? It's not that uncommon at some of the leading tech companies. So when you have a cadence that's that quick, it's not really possible for there to be like a really long quality assurance or a QA cycle, and you really can't have the security team like digging deeply into a release before it goes out. So every push to master or main branch will result in a new deploy, and so you just have a lot of like fast-paced changes. So a lot of people are probably familiar with a tool like Dependabot, which encourages us to keep our dependencies up to date. Whenever we get one of these pull requests, oftentimes we just click merge because we want to stay up to date on the latest version, and it feels like the right thing to do. But whenever we do this, we are introducing new code from a new person out there on the internet. And so it's worth pausing for a moment to just think about what we're actually doing here and whether it's safe to do. And unfortunately, a lot of the tools today don't really make it easy to figure out whether this is a safe action to take. So this pull request here, as you can see, doesn't really tell you much about what's actually going to change. So that brings up the question, like, how quickly should we update our dependencies? So a lot of teams struggle with this question. So as we've started to take security more seriously, people tend to update more often to avoid known vulnerabilities. And so we've gone from a world of the slow updates, which expose us to known vulnerabilities, to a world where we update a lot faster. But in doing this, we also now are exposing ourselves to supply chain attacks, because we're running code that was maybe published a few hours ago, and no one's had a chance to look at it. And so the power of the open source community to find issues and bugs and security issues doesn't really have a chance to take effect when you're running code that was published so recently, yesterday or last week sometimes. So that's really the second reason, I think. And then kind of the third reason is that the cost of attack has become really, really low recently. So the reach of specific dependencies is so large that if you compromise it, you can affect so many people. Even if you're not a brand name company, or you're working at a big, you're working if you're not working at a large company, you still might be affected because of the reach of these attacks is just so far. So, for example, this is an attack that happened last year when this tool called the Amazon Cloud Development Kit, or the CDK. Users were left stunned when they went to go run the CDK command, and then the output that was printed was what you can see here on the screen, a bunch of gibberish. And these messages were just kind of really confusing for people, and it caused an infinite loop, and the whole tool didn't work. Some people thought Amazon was compromised, but what actually happened here was much simpler. A single dependency was compromised, and that dependency had 2.5 million weekly downloads. So it was used by almost, just everybody, right? And it is also used in 29,000 public repos according to GitHub. And so this is kind of the effect of like one dependency going bad. It just affects everybody. So they did it using a technique we'll talk about in a bit if we have time. But basically, it used this technique that's called an install script that is used by almost all malware out there. About 94% uses this. So it's pretty wild.
I think
I'll just pause for a moment here. Sorry, go ahead.
No, it's like, I think when you're talking about the cost of like the lower cost of creating or spreading cybersecurity attacks, I think one of the thing as well that I personally didn't know before, and I realized relatively recently, is also that there's a small cost of also creating these different types of attacks. And I feel like for somebody who doesn't know much about cybersecurity, you might think that you need very specific knowledge to kind of create ransomware or any kind of attacks like that. But when I started looking into it, I was actually surprised that, on a Sunday, in a couple of hours, like I could create my own little ransomware. So obviously, I didn't add it into a tool like, Amazon Cloud Developer Kit or anything. But it's really interesting to see that, with a bunch of JavaScript and a bash script and trying to hide something in, if nobody is actually trying to secure their code with any tool out there, it would be relatively easily to spread even something super small. Sometimes if I was a small attacker, I might not go for Amazon like right away. But if I just want to try, I want to check, is even just one person, are they going to install my package without realizing that they're doing that? So obviously, again, like when I'm doing it, it's for educational purposes. I always feel like I need to say this. I'm not actually trying to attack anybody. But I think when we're talking about the cost, it's also, to me, when I realized how easy it was, I really felt like without any real knowledge of cybersecurity, it really kind of brings it back to like, whoa, actually anybody on a weekend could try to do something. And it makes me a lot more careful now when I use open source software, because if I can do it, then anybody can. So I guess, there's the cost of like, it spreads fast, but also you can create it relatively easily. I just wanted to add that.
For sure.
Yeah, like I said before, it's really scary, right? And a point that you made a little while ago, Feross, was, hey, the CDK from Amazon, and now people are thinking, oh, Amazon is compromised. But like you said, it was so much simpler. But the initial thought is just like, oh, wow, can I trust this person or this place with my code, right? Like you don't even know what it is. You don't know what the problem was, but that's the initial thought, right? So it just shows how detrimental those types of issues can be to a business.
Mm-hmm. Yeah, absolutely. Yeah, it's so easy. Like Charlie, you were saying. I mean, it's all it takes is, it's code. So code, we're downloading code from the internet from people that we don't know, and we're running it on our computer without even reading what it does. So it's and I think programmers are a mischievous bunch, honestly. Like I think like you are playing around just to sort of see how it works and how easy it would be to make ransomware. But there are people who start off like that, but then they actually go, maybe I should actually deploy this and then go further than that, and that's where things go wrong.
I have to admit, I had fun, so I understand if people. But yeah, again, not doing it to do bad stuff. But I think when you were talking at the beginning about having the more of like the attacker mindset, it has been very interesting to me to kind of switch my mindset between like the builder, like, and change it to how do I break what I just built? Or, if I really wanted to have fun with what I'm building, like what would be the ways to use it differently? And I guess just because I like to create things, it's a mindset that I like to train myself to have. But obviously I know that some other people would want to do bad stuff with it, but yeah.
Mm-hmm. Yeah, and I mean, people have all kinds of different reasons. I mean, there's obviously the ransomware case that you mentioned, which is purely financial, but there's also like been incidents of political activism that maybe had a good intention but ended up causing damage to people who were innocent bystanders. So there was a case that happened last year that you might find interesting, or maybe you even heard about, where somebody decided to basically delete all files on your hard drive if your IP address appeared to be coming from a specific country that they were protesting. And so a bunch of innocent, developers just, installed this, or the GeoIP might have had a mistake and, geolocated you to the wrong country. And so this code would run, and the way they did it was it didn't actually it didn't RF your files, but it actually would load them in one at a time and replace the contents of them with an emoji of a flower, and just did that for your entire hard drive. And so you think you're just running a simple little npm install, and then meanwhile your drive is being wiped by the software. So that's like another example. There's also been just other cases where people get tired of maintaining their open source, and maybe they want some funding, which is actually a huge problem in the open source community today, just with maintainers getting burned out. And even just a couple of days ago, there's the Core.js maintainer wrote a post that has been going around. Maybe folks had a chance to read it, but yeah, when you have people that are really burned out and on the brink of needing help, it's probably not surprising that you get kind of erratic behavior sometimes, and people putting things into their dependencies to make a point or stuff like that. So there's a whole there's a huge list of kind of causes of reasons why people might do this that go beyond just the obviously criminal.
Yeah.
Right. Okay. So we've seen a good picture about like what are some of those issues, and I even talked about why folks might do some of these types of things. Tell me how Socket can help us like deal with these issues that they pop up. Like I'd love to hear like your perspective of how your tool helps developers out with this.
Yeah, for sure. Yeah, happy to share that. So let's talk about an example of this. So let's take just to make it really concrete, let's take a very specific type of attack. So there's an attack called typo squatting, where it's basically what it sounds like. That an attacker will register a package name that's a couple letters off from the correct package that you actually want to install. So in this example here, there's a package called HTTP errors that's actually a great package. It works really well and has a lot of users. I think it has 52 million weekly downloads, so it's very, very popular. And then there's this other package over here on the right called TTP error. And as you can tell, there's a letter or two missing there. And if you ever accidentally mistype your install command and you've actually accidentally installed the wrong package, this attack can happen to you. And so this second package here is really not okay to use. So I can just show you really quickly like what it looks like, and then we'll talk about like how Socket can help. But if you go to the Socket website, we actually have this really cool tool called the File Explorer, and this shows you the contents of the package, so you can actually dig in and see what's going to happen. What the code is that you're going to be installing from npm. And what's great about this is it's more correct than just going to GitHub to look at the code, because the code on GitHub might not actually match what's on npm. So this is the source of truth here, and you'll notice that this package is running a shell command to download code from a bit.ly URL, and then it's running it. It's making it executable and then executing it. So I'll just make it a little bigger here so you can see. This is not a command you want to run, and if you ever accidentally installed that package with, you made that typo, then this code would have ran on your computer. And it's not even clear what it does because this bit.ly URL doesn't resolve anymore. So
you're saying I shouldn't copy paste this from your slide and like put it in my terminal?
No, if you've already done that, then I have really bad news for you. Do not do that. Yeah. So like, let's talk about how Socket can help. So basically, what it really comes down to is, if you look at a GitHub pull request, you probably have seen something that looks like this diff here. There's really no feedback about what this package is going to do. The code reviewer looking at this would have to really do a lot of research to figure out what this package is going to do, and painstakingly read every line of code in the dependency, not to mention all of its transitive dependencies. So this is really the problem that Socket's trying to fix, is we want to just make it way easier than this to figure out whether this package is safe. So how does that look? I can actually just show you a real demo here. Let me pull it up. But so here's an example. Let me make sure I make this big enough. Can everyone see this?
Yeah, that looks good.
Okay, awesome. Yeah, so here's an example, the pull request that's a developer here who, let's just pretend it's not me. This is a developer that wasn't very careful, sent in a pull request, and they're adding this calendar widget to the app that we have here. And they decided to use a package called Angular Calendar to do that, and it seems pretty popular. They even wrote here in the comment that it has 91,000 downloads per week, which sounds pretty awesome. So let's go ahead and take a look at the code. So we have this big diff here that no one ever looks at for the package lock file, and then we have this line here that shows the dependency being added, and then down here we're actually using it. So that seems pretty simple, right? Now, obviously, like I said, this isn't really telling me much about the dependency, and so it turns out this package actually has some problems, some pretty serious problems. So let's go ahead and go back to the conversation view and see how Socket would let us know about that. So if I scroll down here, you'll see Socket left a comment on the pull request explaining to me that this package is going to do two things that I might not want. So the first is it's going to run an install script. So an install script is a shell command, basically, that will automatically run whenever this package is installed. So that means it's going to run on all the developer machines, the build server, and it's going to run maybe in production too. This is a thing that almost all malware on NPM uses, because it allows them to run their attack code immediately instead of waiting for a later time. And so what we've seen here is that this dependency actually has one of these scripts. So we go ahead and link to it here so the developer can click and see exactly what it's going to do. And then the second thing we found is this telemetry issue. So telemetry is an issue, is a risk that arises when basically a package is gathering data, collecting data on how it's used. So telemetry is not necessarily always bad, but it's not really expected to be in open source packages. So what this means is that data is going to be gathered every time we run this app. It's going to get sent to an analytics service. So both of these risks are not ideal, and so we've surfaced them here to the developer. And in the case of telemetry, even provided instructions on how to disable this potentially unwanted behavior. So just like that, you can get the feedback right away and address the issue by maybe picking a different dependency or by disabling the telemetry by following the instructions here. And that's it. Yeah, that's the main way that Socket is used. So it's really, really simple. The feedback comes right in there to the developer. You don't have to go anywhere else to get it. You can basically see right there that we found some problems and give you the information you need to address them.
Nice. And so I'm guessing what happens is that after we add the Socket service to I'm guessing you had to connect to our GitHub repos or wherever our source repositories are. Now, essentially, you create a bot, right? And I guess very similar to Dependabot, kind of, sort of, maybe a little bit less annoying because Dependabot can be really annoying.
Yeah, it's a lot less annoying.
But I'm sure you guys, kind of look and see, okay, based on some database of vulnerabilities, like these are the things that we think you should pay attention to, right? And just based on you like inspecting the various packages, right? These are things that I think you should pay attention to, right?
Mm-hmm.
And so now I'm guessing at the bottom there's like a merge pull request button or something like that, and we could decide, hey, do we want to keep this or not? And
Yep,
Yeah.
exactly. So Socket's telling us that we have issues here, and of course, I'm free to ignore them and merge anyway if I'd like.
Yeah.
But there's a option within GitHub to actually make this required, so that you actually have to make sure that the issues are addressed if you want to go that far to kind of enforce. But yeah, that's as easy as it is, and we even support like deciding which issues that you want to warn about. So we have like a way to configure this if you want to add more issues or take some away and you don't want to be alerted about them. But it's highly configurable by the end user. But our default set covers the most common attacks that we see happening in the wild today.
Okay. I remember sometime last summer, I have GitHub repositories, and some of them are a little bit older than others. And so I haven't looked at them in a long time. But I mean, it's mostly like, demos and not necessarily code that like I publish to like a package repository. It's just kind of stuff that I have for like, for me keeping. And there was this day last year that I woke up and my phone was just going off like bzz, 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 bzz. This is what happens when you have GitHub on your phone. Do not put GitHub on your phone. My phone is just like going off. I'm like, what is happening? And I go into my email and I kid you not, I had maybe like 60 or 70 email notifications from Dependabot. And I'm like, this is too much. And I went in and I turned everything off, right? But at the same time too, I'm thinking, this is not what I want from a tool whose intention is to protect me, right? Like I know Dependabot wasn't intentionally trying to DDoS my email or kill my phone battery or anything like that. I know that wasn't the intention. But again, I think it's important that we kind of like are able to tweak those settings a little bit, you know what I mean? And sometimes that's us. Maybe I should have done some work up front to kind of, I don't put it in a folder or create filters or something like that, right? But like I think we always need to try and figure out like what's a good balance between, hey, this is a really important notification and this one's not. Or hey, I already notified you about this. I don't need to send you the same notification like 10 more times every time I run. You know what I mean? Like I feel like it's important that we have those types of balances. But it sounds like your tool has like some level of like intelligent filtering that we could kind of tweak how some of those notifications happen. Yeah, is that correct?
Mm-hmm. Yeah, so one of the big differences between Socket and a lot of other tools out there that you might have used before, like Dependabot, is that we focus a lot more on supply chain attacks instead of just vulnerabilities. And one of the reasons is because of the signal to noise that you just mentioned. Vulnerabilities happen all the time. I mean, there's so many of them. There's new vulnerabilities discovered every day. And the thing about vulnerabilities is that most often they're an accident. They're introduced by the maintainer. It's basically a bug, security bug. And the thing is that you usually have some time to fix these. You're not going to immediately get attacked. I mean, that's not always true. There are exceptions, but the vast majority of vulnerabilities are pretty low impact, and you have some time to remediate them. And so when a tool just starts alerting you about them constantly, right, then it starts to train you to ignore the tool. So developers ignore Dependabot a lot, right? They ignore any tool that just constantly cries wolf, right? And part of, I mean, I care a lot about security, and even I ignore Dependabot, right? And same thing with npm audit. For those of you who have used npm install, whenever you install something, you'll get like a little message at the end that says you have 1,000 vulnerabilities, and most of us just see that and say, okay,
all right, it's Tuesday, whatever.
Yeah, exactly. So it's to the point where everybody ignores it, so you know that it's really not helping. And so it would be much more useful if we were able to ignore the really low impact vulnerabilities. And so that's one of the things that Socket is trying to do better, is by focusing on supply chain attacks, which are always malicious and which you never ever want to run, because you're literally talking about code written by an attacker. This is something that you need to catch before you install it, and it's never okay to run it even once. So it's very, very different than vulnerabilities, right? It's actually just much more severe. So by focusing on that, we're able to be much higher signal to noise, because we're not going to alert you about every single, regular expression denial of service vulnerability that happens in your dev dependencies, right? So it's much more high signal.
Yeah, that makes sense.
So hopefully that approach makes sense.
Yeah, it definitely does. So as we're talking about that, like that for me, it sounds a lot like the usability. Like, what's that user experience like? Like, how much do I have to do upfront to get like the right level of alerting? You know what I mean? Versus me just like showing up and turning it on and like, whoa, let's see what happens, right? I think a lot of it has to do with like how we as engineers think about like designing the tools. And so with that being said, I'm kind of curious. So we see that you all can plug into GitHub. Or like, are there other integrations that you could plug into different places, and I know like extensions and things of that nature that we could use to help identify these things?
Yeah, totally. Yeah. So I can show you a few here. So we have a CLI tool, for example, that you can run. Is that big enough to see? Hopefully everyone can see that.
Yeah, that's good.
Yeah, and this will let you. Okay, awesome, cool. Yeah, this will let you look up package information. So if you did want to kind of ask yourself like, hey, do I need to worry about installing, let's say, I'm looking at installing a package, and I want to find out if it's safe. Let's try maybe React version 16. You can run this command, and I'll be able to get back some useful information. And the cool thing about this is you can actually get back the data in a JSON format, and you can pipe this into your own tools. So you can look for specific issues that you care about. I'm not sure why this is taking a minute here. Of course, the demo gods are not on my side as usual.
Listen, anytime that you're streaming anything, your dev tools know, and it's like, I'm going to make you sweat just a little bit,
Yeah, exactly. Let me try. Let me try maybe a more recent version of React. Let's try like 18.2.0, which someone's probably looked up recently, so it's cached. Yeah, so here we go. Package has no issues. Yeah, pretty useful, right? And then if you wanted to get like the full list of like things that we know about this package, you can actually pass a JSON flag, and then you'll get like this is like getting the fire hose of issues. But if you look through this, you'll actually be able to see that one of the dependencies has an unclear license, for example. You'll get that some of the dependencies have no tests. And you can kind of, if you really wanted to dig in and really know everything about React, you could really get like a lot of data here about your dependencies and use this in your own tooling. But we expect most users probably wouldn't want to do all of that. But that's one example. You can also hook us into your CI system by running socket CI, and then if you do that, we will. I'm not gonna run it right now because it'll take a little bit of time. But if I run this command, it'll actually send my package JSON up to socket, and we'll analyze both it and the corresponding log file, and then we'll produce a report with a really detailed analysis of all the issues that are present. And then because we use the CI command here, this is actually going to return an exit code that will fail when there's critical issues present. So you could put this into your tests if you wanted to use it that way.
Nice.
Yeah. Yeah, so that's one example. There's also a VS Code extension that we have as well, which folks can download. Yeah, it's pretty cool. It shows you inline alerts, and let me see if I can pull it up here really quickly. Let's see. I should have had this one ready to go.
No,
already.
that's fine. but I do like that CLI example, though. I think that's really cool. I feel like every tool today should have a CLI. Like that's just the way that the world is. But not only just for the fact that it's cool, but for the fact that, like you said, we can plug it into like our build steps, our CI systems, our local testings, and some of those types of things. Maybe there might be a VS Code extension. I don't know, that like helps us like pick these things up like as we go. I think that those are all really good use cases.
Yeah. So I'll give you an example here of the VS Code extension. I got it running. So you can see in my
You do have a VS Code extension? I was just joking. There's one?
No. We actually did, yeah.
Oh, no way. I was just joking. I had no idea.
Yeah.
That's cool.
Yeah, no, we do. It's cool. Yeah, so this is an example of it in action. So when you're looking at your dependencies in your package JSON, you can actually hover over anything with a yellow squiggle, and it'll tell you whether there's a risk present. So in this example here, you can see this has an install script. So if I was curious, I could dig in and go like see exactly what it does, but I can ignore it or basically mark it as safe. So you can go through these and see like what the risks are in each of these packages.
That's very
cool. Yeah, and then we even show it inline too. So over here, you can see in this file, you see the little bit of feedback from Socket here around to get, for example, you can see that Sentry has 6,000 lines of code, 7 dependencies, 3 transitive dependencies, and then you can see kind of all the issues here if you're curious. But it's really fun to look through because you can really see like which of your dependencies is hiding a lot of complexity. So like sometimes you hover over one of these and you'll, like for example, I'm sure none of us are surprised Next.js has 338,000 lines of code, right? But being able to see that right there, it gives you a sense in a way of like how much how much is going on there in that dependency that you might not realize from just looking at this single line here that looks so innocent.
Yeah, that's crazy.
I don't know if you also want to show, because you know how you were saying that sometimes you can install a version of a package that has some kind of issue, but only in that version, whereas the previous versions, all the versions after, have actually been cleaned up or anything. So it means that if for example, if you're installing React and in version 16.1 there's an issue, but in 16.2 there's not anymore. What I've done in the past is I've used the dashboard, the Socket dashboard, to kind of switch between versions of certain packages, to be like, okay, maybe I shouldn't install version 16.1, but it looks like 16.2 is okay. So I shouldn't completely, forget about using that package, but just making sure that, I use the version that doesn't have any issues. So is there, because through the Socket dashboard, it's kind of easy to switch between versions, but is there a way to do that, like with either the CLI or, is there like an indication of like, hey, we found that in that version, there's an issue, but if you use another version, then it's fine.
So I don't think we have a very clean way to do that in the VS Code extension yet. We just published this a couple of weeks ago. So what I can show you though is how it works on the website. So if you go to Socket and you were to search for a package that you're curious about, let's say Lodash, for example, you can get you get this really nice search results page. Let me make this bigger so folks can see it. And we're trying to be more useful than the official package sites here. So we have like scores about the quality of the package, the security, the maintenance, the vulnerabilities, and then whether the license is safe to use. And so as you scroll through here, you can see some packages stand out as having like lower quality than the rest. But let's go ahead and select the first package here. And right away, you can see we've identified one risk of this package, which is that it uses eval, which is a dangerous function to use. So you can go ahead and click in and see exactly where it uses it if you're curious. But overall, you can install the package. I mean, look at the scores. It has 100 out of 100 on security, and 81 on quality. Probably the quality is a little, and the maintenance are a little low just because its last version was published 2 years ago, which is not that recent. But yeah, overall, you can tell this is a good package. But let me show you one that maybe isn't, maybe one that has a couple more risks that you should know about. So here's a package called event source polyfill. And this is actually one where the maintainer at one point decided to protest something and added unwanted code into the package. And if you were to go to the NPM website or just like look at a normal the GitHub page for this package, you would not know that any of this code had been added because there was no indication that anything had happened. But as you can see on the Socket website, we have this nice warning that this package contains protestware and it contains, in this case, undocumented or hidden behavior. And if you're curious, I can actually just jump in here. If you go to the file explorer, you can actually just see exactly what that code is. So if I go in here, actually there's a faster way to find it, which is to just click the link to the direct line of code, which I think I've already. Let's see, where is it? I'll just scroll to it. But for now, it's fine. Just to show you all. Here it is. So down here on line 1032, you can see that they've added some code which detects your time zone. And then if your time zone happens to be in any of these time zones, then they're going to run this. This following code. And what the following code does is, first of all, it produces a bunch of flags of Russia and Ukraine, and then it has a bunch of Cyrillic text down here. And then probably the most significant part in terms of the security is that it opens up a window to this website. And it does it after 15 seconds. So this is in a set timeout with a 15-second wait time. And so what this basically means is if you accidentally use this package, or if you were using it already and just happen to update it, that now your production website is going to start redirecting your visitors to this URL, which is, no matter what the cause is, probably not something that developers expect from their dependencies. So so this is something that we obviously want to warn people about. The other cool thing I can show you in terms of just detecting this type of thing is we have these really handy diff pages. So if I go down to that specific version 1026 and I click on the diff link here, you'll actually see you can just see exactly what changed between the two versions. So this is exactly the diff in the npm package. So obviously the version changed. You can see that code was added that I just showed you, and then the minified file changed, and that's basically all that changed. So this stands out like a sore thumb if you're actually reviewing your dependency updates, because you're like, wait a minute, what? Why are there emojis in my source code? And then you can see it right there. So this is the kind of thing we want to provide this context to developers in their pull requests when Dependabot or whoever is trying to get you to update, to be able to click in and see, okay, what's actually going to happen if I do this update, right?
That's really cool.
Yeah, and so you can see here, this is the new issue that was introduced in this version, right? Protestware was introduced in this version 1.0.26.
Yeah, it's crazy to see that, because I can imagine being a developer and just writing and going about my business, and all of a sudden windows are popping up on my screen, and the panic I can imagine, like, oh my goodness, like, is that my machine? Like, where did that come from? Because now you're trying to find out where the problem is, right? And yeah, I can completely see how that would completely throw off my day. But something as simple as a set timeout with an open window.
Yeah, for sure. Yeah, people don't expect their dependencies to do that type of thing.
Yeah.
But yeah, hopefully this is. Hopefully this has been giving people an idea of how to use the Socket website to look up packages. It's really quite helpful to see this type of information. One other thing I wanted to show you that kind of drives the same point home even further is we actually at Socket anytime a package is removed from npm for security reasons, and you can if you go to our footer and you click the remove packages link right here, you'll actually be taken to this page. And so these are all packages that have malware in them that have been deleted, but we have a copy of them at Socket, and we're actually making them available to people to look at for research purposes. So you can click into any of these and see exactly what the package would have done if you were unlucky enough to have installed it before it was caught. And I just had a couple examples I wanted to highlight here that are kind of interesting. So one package here is called Web3, but has two B's. So if you're ever unlucky enough to make that typo, then this is the nice package you'll get. And obviously you can see the scores here don't look too hot. We have a score of 27 on security, 25 on vulnerabilities, and then if you scroll down here, you just see the whole page is basically filled with warnings about do not use this package. So you can see it has a critical CVE. We detected it as a typo of the much more popular Web3 package with the correct spelling of the package name. You can see that the correct package has more than 300,000 times as many downloads, which is obviously not a good sign for this package. And then it's been unpublished, installed scripts. It has dependencies that are deprecated. It has a lot of problems basically. But just to jump into like one specific problem here, if I click on install scripts, I can see here that it's running this command node index.js automatically. And if I'm curious, I can click in and see exactly what that's going to do here. So if I click in, this file is running automatically whenever the package runs. And if you just scroll down here, you'll find that there's one particular line that's quite interesting, which is this one right here. Actually, there should be a little alert message over this too. Let me refresh and see. Oh, there we go. Now it showed up. Yeah. So basically, this is a command that you really don't want to run. wgetting this bitly command. I think I showed a similar command on the screen earlier as well. But this is just slipped in here, like in the middle of this file. And also, look at this. I didn't realize there's this comment here. That's, oops. But yeah, it's a Linux only attack. So yeah, and then I have another one here that's kind of crazy as well, which is one that has, again, very low scores. It's already been removed. But you can see here that Socket would have detected a few interesting things. The one I'll just point out here is obfuscated code. So if you click in here, you can see we have a pretty high confidence that they're trying to hide their behavior on this file. And if you click into it, you can see exactly what's going on. So this looks initially like a minified file. Maybe you've seen minified code before, but this is actually even worse than that because it's actually it's designed intentionally to hide the behavior of the code. So everything is actually wrapped in a big eval, and then it's like, you know, parsing all these numbers and doing all these crazy operations. This is very, very difficult to reverse. But yeah, this is not something that you want to run.
Yeah.
How do you calculate the confidence of minified code being malicious? Because minified code is hard to read in general. So how can you say that, oh, it's 0.9 and not 0.5 or anything?
Right. So there's a difference between minified code and obfuscated code in that minified code actually still has quite a lot of structure to it, and you know it still has. It still has a lot of what's the word for it? Like order, I guess, to it in the sense that it still kind of runs as code, and there's still a lot of structure to it. But when you look at obfuscated code, when they're using a technique like this one is using, it looks much more like a uniformly random like file. So if you look at the just kind of entropy of the file, that's like one really strong indicator. So if you look here, it's just like mostly random numbers. And so if you think about like just measuring the kind of randomness or the entropy in the file, that's like one way that's one of our techniques that we use to detect it. Yeah.
That's cool. Okay. It's funny that you're mentioning like typo squatting, because just this morning I was trying to install like .env and I made the typo. Well, I mean, then I was like, no, I just got the install. I mean, I checked and what I wrote isn't actually a package that exists. But it's funny how when you're trying to go fast, it's really something like, it just happened to me this morning. So
yeah. And one of the things we're hoping that we can do with our CLI in a future version is actually to help you catch that even on the terminal. So instead of having to go to our website or to wait until a pull request to get the alert, to actually be able to do it, basically to intercept your npm install command.
Yeah, that would be super useful. Yeah, for sure.
Mm-hmm. Awesome. So folks, we have just a couple of minutes left. But before we shut it off, I want to say thank you, because you showed us so many different. Well, you've had me think about so many different things that I wasn't thinking about before when it comes to like securing our applications. And, I'm just thinking as, because at Stripe, we move money, right? And so when you think about the importance of securing your applications that are moving money, like that's not a trivial thing to consider, right? Definitely not something you want to leave to the end like I do. So, just FYI, you want to do that up front. So if I'm a developer today and I've sat down, I've watched the stream, I've seen all this stuff, and I'm like, okay, cool. What do we do now? How exactly do I get started with Socket, right? Like, is it in beta? Is it fully out? I don't know. Do I pay you guys like $5 a month? What do I have to do, I guess, to get started?
Yeah, totally. So the easiest way to get started is if you just go to the homepage, socket.dev. You can actually just click install GitHub app, and from there you can get started using it right away. Okay. And if you're using it at a larger company and you want to have a demo with us to actually talk through like what it would look like to roll it out, and you want to talk about kind of more enterprise features, then you can click book a demo and then schedule time with Amjed, who's up there on the call, and Amjed will walk you through kind of all the more enterprisey aspects of the product. But yeah, so it's free for open source. So folks who want to use this on their own personal projects are free to jump in and use it. But if you're using it in a larger company, then you should probably look at the pricing page to get a sense of kind of the way that the plans work, which you can find here in our header.
Got it. And I know today that it's obvious, like it's very primarily focused on JavaScript and npm packages right now. Is there any thought about expanding to other languages, like I don't know, like Go and Java and Python, for instance, like anything else like that on the pipeline?
It's funny you should ask. We actually
I knew this from before.
Yeah, so if folks stay tuned, very soon we might have something to announce in that area.
Ooh, that sounds amazing.
Yeah.
Yeah, and just I would say keep an eye on our blog in the next couple weeks, and you might see a little something about that.
Okay, great, fantastic. Well, gentlemen, thank you both for coming on. I mean, this has been really amazing. We've been showing the links and things like that, like as you all have been talking, and it seems like there's been a lot of good conversation happening inside of the chat. So folks seem to be definitely like on the positive side of things about definitely giving Socket a try. So yeah, I think this is really cool. For me, for sure. Like I don't write a lot of JavaScript applications. So I'm gonna like peep over Charlie's shoulder as she's writing stuff and be like, make sure you use Socket because it's they'll wait until the end to do it like I do.
Right.
But again, just thank you both for coming on. Right, really appreciate it. And if sometime in the future you have anything fun and interesting you want to share, definitely feel free to let us know. We can always have you come back.
Yeah, we find interesting stuff all the time out there. So I'd be happy to share when we have something cool to come back and talk about. But thanks again, both of you, for having us. It's been super fun, and we love this stuff. We love to talk about it. So thanks for giving us an opportunity to share this with the developer world and the broader community.
Awesome. Well, again, gentlemen, thank you all so much, and thank all of you for watching. This has been another episode of Stripe Dev Chats. Definitely make sure you check us out every Wednesday here on the Stripe Developer channel. Hit the like button, subscribe button, and all those YouTube-y things that people like to do. And we'll see you all next time. Okay, bye.
Yeah.